In the last video, we explored the difference between distance and displacement. Distance describes how far one point is from another. It only has a magnitude and it does not have a direction. So distance has a magnitude. It does not have a direction. Displacement, however, describes the difference between your initial position and final position. So when we ask about your displacement, we want to know how far you moved from your initial position and in which direction. So in displacement, we want to know the magnitude and we want to know the direction. Okay, so this is essentially the difference between a vector and a scalar. So vector has magnitude and direction, and scalar only has magnitude, no direction. Another example of a vector and a scalar is velocity and speed. Velocity is a vector, speed is a scalar. So when we ask about your speed, we only want to know how fast you moved. But when we ask about your velocity, we want to know how fast you moved and to which direction. So we know the vectors have direction, but how do we describe this direction? To describe the direction of a vector, we need to start with a coordinate system in a reference frame. So let me draw a coordinate system here. This is a two-dimensional coordinate system. So by tradition, we call the vertical line the y-axis and the horizontal line the x-axis. In most cases, we assume the upward direction in the y-axis is positive and the downward direction is negative. And we assume the right direction of the x-axis is positive, and we assume that the left direction is negative. However, this is not a written rule. In some problems, it is actually more convenient to assume the opposite. For example, in a falling object problem, it is more convenient to assume that the downward direction is positive. Okay, so now let's look at only the x-axis. This is your origin, point 0. Let's say we have 1, 2, 3, and let's say this is 4. And now let's assume that you move from one point, like point x equal 2, to another point x equal 4. So this is a one-dimensional movement. So we only need a one-dimensional coordinate system to describe this movement, and that's why we only have the y-axis. So let me show our displacement from position x equal 2 to position x equal 4. This is it. We show vectors by arrows. These arrows have lengths, that this length is proportional to the vector magnitude, and the direction of the arrow points towards the vector direction. So now let's say, what if I want to show the movement, the displacement from point x equal 4, like here, to the point x equal -1, here. This is how we show it. So now I have this arrow that points to the left. So our direction is to the left. And you see that this is a longer arrow because we have a bigger vector. So you see that the length of the arrow is proportional to the magnitude of the vector. Okay, so I hope that you learned the difference between a vector and a scalar and how to show a vector on a coordinate system.